The 19th question says you have 6x plus 7, that is a linear, upon root of x minus 5, x minus 4. Once again, root of quadratic. So how do we handle this? The way to handle this is, once again, in the denominator you have x. Let me write this expression first of all in another form, that is, this is 6x plus 7 is okay, and in the denominator you have x square minus 9x plus 20. Do you observe this? Yes. There is x square minus 9x plus 20. And after this, I'll start from here. And let me write the numerator. That is 6x plus 7 as a times the derivative of this, which is 2x minus 9, derivative of this denominator, quadratic, plus some other constant b, right? This is what you have. And this is always equal to this, therefore we can compare coefficients. Comparing tells me that 6 will be equal to 2a or a will be equal to 3. This is the first thing that I observe. Yes. What else? 7, that is a constant term, will be equal to minus 9a plus b. That tells me b will be equal to 7 plus 9 times a. 9 times a is 9 times 3, 27. 27 plus 7 is 34. This is the value of b. This looks pretty big, but this is what you have, right? Plus 34. Yes, plus 34, right? So therefore I is equal to a times 2x minus 9 upon this, which is 3 times integral of 2x minus 9 upon under root of x square minus 9x plus 20 dx, and plus b, which is 34 times integral of, this numerator will be 34 times dx upon under root of that whole expression, which is x square minus 9x plus 20. This is what we have. This is what we have, right? Now, integral of this has to be found, integral of this has to be found, and then we get a final answer. This is actually 3 times I1 plus 34 times I2. Okay, and our target is to find I1 and I2. Our target is to find I1 and I2. Let's try to find I1 first. I1 is pretty simple, looking pretty simple, yes. Because this is nothing but 2x minus 9 upon x square minus 9x plus 20. So we can take x square minus 9x plus 20 as t. This will be a derivative of this. So this actually becomes dt upon root t integral, which is 2 root t plus c1. This becomes 2 root of x square minus 9x plus 20 plus c1. You can write it as this, c1, right? This is I1 for us. Okay, is that all in I1? Yes, that's all in I1. After a lot of practice, what you can do is you can simply go from here to here, right? This is nothing but dt upon root t, so that becomes 2 root t, and therefore this. Okay, those steps can be done orally as well after practice, lot of practice. I2 over here. By the way, right now I have written all the steps, all the required steps except for one, that is x square minus 9x plus 20 has been taken as t, right? The derivative should be there in the numerator because that's what we have done, that's what we begin with, that's what we planned for, right? Okay, I2 is this expression. So for I2, I do make this into a perfect square, right? So instead of finding I2 first, what I'll do is I'll begin with that x square minus 9x plus 20 and convert it into a perfect square. This is x minus 9 by 2 square, x minus half of 9, which is 9 by 2 square, and this 9 by 2 square has to be subtracted. That becomes minus 81 upon 4 plus 20. Okay, and this is equal to x minus 9 by 2 squared plus 80 minus 81 is minus 1 by 4. This is what I get. This is what I get. X minus 9 by 2 square and minus 1 by 4 is what I get. 1 by 4 is square of 1 by 2. Yes, that's okay. But once I have converted this, therefore I can write I2. I can write I2 now. I2 is equal to what? Integral of dx upon square root of this expression, which is this, x minus 9 by 2 square and minus 1 by 2 square over here. Yes, and this is nothing but under root of x square minus a square. The formula says this will be log modulus of x minus 9 by 2 plus under root of this whole expression, which is equal to this modulus plus constant of integration C2. This is I2 for us, right? Once you have found I1 and I2, now I can write the value of I. Therefore, I is equal to what? This is equal to 3 times I1. 3 times this, which becomes 6 times under root of x square minus 9x plus 20. Okay, and plus 34 times I2, 34 times this. 34 times log of modulus x minus 9 by 2 plus under root of this whole expression, which is x square minus 9x plus 20, the modulus along with that, and I1 has constant C1, I2 has constant C2, they will combine together to give C. That's what we have, right? 3C1, 34C2 will combine together to give this C, and that's the final answer for this 19th question, as we can see over here. That's all? Yes, that's all in this 19th question.